this video, we will try to solve some simple problems on overcurrent relay. Look at the first problem. We have a bus bar and there is a feeder, and to this bus bar there is a current transformer CT. The CT rating is given as 400 by 5 amperes, and the current flowing in the primary of the CT is given as 300 amperes. And we can see that this CT is connected to an overcurrent relay, and this is the relay coil, and the output of the relay is the trip contacts. So let us come to the question. An overcurrent relay fed from the CT having a rating of 400 by 5 amperes with a pickup current of 4 amperes. So pickup current is given here. We have the pickup current as 4 amperes. Pickup current of 4 amperes. If 300 amperes flows in the CT primary, so we can see that 300 amperes is flowing in the CT primary. Find whether the relay operates or not. So they are asking us to find out whether this relay is going to operate, in the sense whether this relay is going to close the trip circuit or not. So for an overcurrent relay to operate, we should know the condition is that the relay coil current IR, let us call it as IR, should be greater than as I pickup. So when the current seen by the relay, so let us call it as IR. So if this current exceeds the pickup current of the relay, then the overcurrent relay will operate. So let us try to find out what is the relay coil current. So pickup current is already given, and we need to find out the relay coil current IR. So relay coil current IR equal to, see, relay coil current IR is nothing but the secondary current of the CT. So primary current of the CT is known. CT turns ratio is also known. So we can easily calculate the relay coil current. So relay coil current equal to CT primary current multiplied by CT ratio. So IR will be CT primary current is 300 amperes multiplied by CT ratio 5 by 400. So that will be around 3.75 amperes. So we got IR. Now we just need to make a comparison between the pickup current and the relay coil current, and we should see whether this condition is satisfied or not. If the current seen by the relay IR exceeds its pickup, then only the relay will operate. Here IR 3.75 is less than the I pickup. So the question being asked is, find whether the relay operates or not. Since the relay coil current is less than pickup, we can say that relay doesn't operate, does not operate. Let me go to the second question. So the relay is actually connected, this relay is actually connected to the CT like this. So this whole setup from now I will be showing in this form, this symbol. So here also we have a feeder and a relay coil. This is the relay coil, and to this relay coil there are different tap settings. So why these tap settings are present, I have already explained in my current setting video. So these tap settings for this relay coil will help to adjust the pickup current of the relay, So let us come to the question. A 400 amps, a 400 by 5 amps CT feeding a relay coil. So this CT is feeding this relay coil with a different current setting. So it is having an option to choose the appropriate value of current setting. Find the pickup current. So they are asking us to find out the pickup current. If current setting is 70%, so if this pointer is connected here, 80%, 100% and 120%. So here we need to find out the pickup current of this relay coil depending upon the given current setting. So let me first write down the pickup current formula. So we know that I pickup equal to rated CT secondary current multiplied by current setting. So the given value, so they asked us to find out the pickup current for these current settings only. Let us suppose the current setting is, first case, the current setting is 70%. Okay, 70%. So in this case, I pickup will be rated CT secondary current. So CT is a 400 by 5 ampere CT. So the secondary current rated secondary current of the CT is 5 amperes. So rated CT secondary current is 5 amperes multiplied by current setting. So in this case, the current setting is 70%. So we can take 70 by 100. So it is 7535. So we have 3.5 amperes here. So if the current setting is at, so if this is connected at 70%, then the relay pickup will be 3.5 amperes. If the relay pickup is 3.5 amperes, if the relay coil current IR exceeds this 3.5 amperes, then the relay will consider that current as fault current. So let us take this second. Similarly, we can calculate for all these settings, right? For 80% setting, I pickup equal to, again same formula, rated CT secondary current, which is 5 amperes multiplied by the current setting. Here the current setting is taken as 80%. 80 by 100. So 5 8 40. So 4 amperes will come here. So the third setting is 100%, right? So at 100% setting, we have I pickup equal to rated CT secondary current multiplied by 100. So that will be 5 amperes. The last one, 120%. So I pickup equal to rated CT secondary current multiplied by current setting. So current setting here is 120 amperes. So 12 by 60. So 6 amperes will be here. So we can see that by changing the current setting value, maybe 70%, 120%, 100% or 80%, we can get different pickup currents for the relay. Let us go to the next problem. Here there is a bus bar and there is a CT connected to a relay. The CT rating is given as 400 by 5 amperes and the primary current of the relay is given as 300 amperes. The primary current of the relay is given as 300 amperes. So let us come to the question. An overcurrent relay being fed from a 400 by 5 ampere CT. So 400 by 5 ampere CT. If the current in the feeder is 300 amperes, so we have got the current in the feeder is 300 amperes and the current setting of the relay is 50%. So they have given the current setting of the relay 50%. Find out whether the relay operates or not. So as usual, for the relay to operate, we know the condition. The relay coil current should be greater than the pickup current. So whatever current that is flowing into the relay, so we have relay here, it should be greater than the pickup current. So from this question, we need to calculate relay coil current and pickup current. So let us first calculate relay coil current. So IR equal to, so 300 amperes is flowing in the primary and we have a CT with a ratio of 400 by 5 amperes. Just we need to calculate IR. So 300 primary current multiplied by CT ratio. CT ratio is 5 by 400. So we will have 3.75 amperes as the IR. Now we need to calculate I pickup. I pickup equal to rated CT secondary current multiplied by current setting, right? Current setting. So rated CT secondary current is 5 amperes here. The CT is having a 400 by 5 amperes. So 5 amperes is the secondary side rated current. 5 multiplied by current setting is given in the problem as 50%. Okay, so if you take 50% as current setting, then 5 is 25. We have 2.5 amperes. So the pickup current is just 2.5 amperes for this relay. But the current seen by the relay IR is 3.75 amperes. So we can clearly see that the current seen by the relay IR or the current flowing in the relay coil is greater than its pickup. So this condition is being satisfied. If this condition is being satisfied, the relay operates. So we can say here IR is greater than I pickup. So the relay operates. Okay. So in my next video, I will try to solve few more problems. I request all of you to subscribe to the Easy BTech channel. Thank you.